Problem 7 is a law of cooling problem, an exponential decay problem. As the temperature of a hot bowl of soup declines from some hot down to manageable temperature, 100 degrees is what I want to find, when it's equal to 100. And they give me this formula. But several of you, when you were asking about how to set this up, weren't sure where those numbers were coming from. What does 72 and 140 have to do with the problem? Well, let's draw a typical decreasing temperature problem over here on the left. The idea is the exponential part. When t gets bigger and bigger, that exponential part is going to get smaller and smaller because it's to a negative exponent. And so that part disappears, and all you're left with is the 72. So the 72 is your room temperature, what you level off at as your temperature decreases, right? And so that 72 is the horizontal asymptote for this problem, the room temperature. What's the 140? Well, the 140, turns out that's the difference between where you start and where you end up. So this temperature decrease starts at 212, which is boiling, I guess is why they picked that number. And so it has to decrease 140 degrees from the beginning temperature to the horizontal asymptote temperature, the ending temperature, the surrounding temperature of the air. And so you have to decrease that 140. That's what those two numbers represent in the problem. And so you want to figure out when it ends up being 100. So you set this equation equal to 100. And first things, you subtract the 72 because it's added over the other side. And it's still 28 degrees above room temperature. And if it has to decrease by 140, this is the fraction of that decrease. It still has to go. So you divide by 140 to get that. And now you've got e to a power on the other side. Take the logarithm of both sides, and we'll use the natural logarithm in this case, not log, but ln, because that undoes, that is the inverse of the e base exponent. And so we get the natural log of 28 over 140 equals negative 0.08t. And we solve that for t, and it turns out it's 20.1, and this rate was given in minutes. T is minutes. So that takes 20.1 minutes for the soup to cool down to 100 degrees.